word. Okay, so today we're talking about, what are we talking about again today, class?
Theoretical possibility of combined events.
Good. One. Yes. Okay, good job. So what that means is we have more than one thing happening, but in the case of, for example, a card, or a bunch of things, we would put the thing that we draw back into the stack or into the mix, and it would not affect the second event. Okay, so we're learning two different methods today. We're going to solve these problems mathematically, and we're going to solve them using a chart. All right, so here's an example. Zach, we're also going to learn a few different terms, like fancy terms for things that you already know, but it's important to know the language that belongs with the topics, and to be able to associate this math vocabulary with the things that we're doing. Okay, Zach rolls two regular six-sided dice. Find the probability that the sum of the scores on the dice is a multiple of 5. Okay, so the first thing that you notice here is that Zach says the dice are unbiased. What that means is that there's an equal chance of getting a 1, 2, 3, 4, 5, or 6. Could the dice ever be biased? Could that happen? Sure, the dice could be weighted, perhaps, or maybe you have a trick die with like two sides that are 2s or something like that. But yeah, I don't know. Okay, so Zach says there are many possible outcomes and we need a systematic way to show all the outcomes. So the first thing that we're going to do is take a look at the chart that has been constructed for you. Okay, so up here on the top, I have what the first die could roll, right? So 1, 2, 3, 4, 5, or 6. Okay, and then along the side here, I have the second die, 1, 2, 3, 4, 5, and 6. And then within the grid, I have the different possibilities of sum. Okay, so if I roll a 1 and a 1, what's my sum going to be? 2, right? If I roll a 2 on the first die and a 1 on the second die, what's my sum? 3. Good. If I roll a 3 on the first die and a 1 on the second die, what's the sum? 4. Good job. And so on. You guys see the pattern? Okay. Now I have possibilities over here. I could roll the same sums, but backwards, couldn't I? So for example, if I roll a 1 on the second die and a 6 on the first die, what's my sum? 7. It's right here, right? Okay. How many possible outcomes do I have? I have how many? I have 36. Okay. So you can see we have 36 because we have all of the outcomes listed on the chart. We can also arrive at the number of 36 by multiplying 6 times 6, right? We have 6 possibilities on the first die and 6 possibilities on the second die. Does that make sense to everybody? When I look at these charts, I'm always reminded, I told this to my Yale group the other day, I'm always reminded that they look like multiplication charts. And they're not, because these aren't products that are in the middle here. At least on this chart, these are sums. But the outcomes, since we have 6 outcomes on each die, we have 36 possible outcomes. Yeah, 6 times 6. Why is it multiplied? Do you mean why do we multiply the outcomes by the outcomes? Yeah. That's a great question. So the reason it's multiplied is because, let's take a look at this first die, okay? Let's say we roll a 1 on the first die, right? We have as many outcomes associated with that 1 as possible outcomes on the second die. So if we roll a 1 on that first die, we have 6 possible outcomes with the second die rolling different numbers each, right? Does that make sense, Gabby? Okay, so that's a total of 6, right? Because there are 6 on each. And this is unique to this case. This is because we're using dice with 6 sides each. Now, if I roll, Gabby, if I roll 2 on the first die, I have another 6 possible outcomes with whatever rolls on the second die, right? So that's 6 there. If I roll a 3, I have another 6 possible outcomes. and so on and so on. So remember, multiplication is just repeated addition. And so what I'm multiplying is this row by this row. So 6 times 6. So it's just meaning that, you know, for every outcome on that first die, I have 6 possible outcomes that could happen. And so by multiplying those, I get my answer quickly. But I like that you answered. You asked why. Okay, so what are we looking for? We're looking for the number of outcomes where the sum is a multiple of 5. And so on your chart, you've had all of the 5s circled and you've had all the 10s circled. And so you can see from your chart that you have how many possible outcomes? 7, not 8, 7. So the probability that the sum is a multiple of 5 is 7 out of 36. Good. Okay, so the score on the second die. So if I'm rolling 2 dice, you guys, this is where the term independent events comes in. If I'm rolling 2 dice, does like what I roll on one die affect the other die at all? No, right? Unless they're like magnetized or something. No, it's not going to affect, one die is not going to affect the other die. So that's what we called independent events. It's just a fancy word for it. Okay, so let's do another one. So Marcel randomly picks a coin from a box containing a nickel, a dime, and a quarter. He returns, this is a key, whoopsies. Go back. He returns the coin into the box before picking another coin. Find the probability of Marcel picking the same coin twice. Nora.
Is it 1/3?
It is. You want to tell me how you got there?
Yeah.
Yep. Okay. Good job. Yeah, very, very well done. So Nora said that there are 9 possible outcomes, which you guys can see from the chart here. We've got nickel, dime, quarter, and nickel, dime, quarter. And so this chart shows all of the possibilities that we could draw with one and then another draw. And so you can see that there are 3 times when Marcel could possibly pick the same coin 2 times in a row. So that would be 1/3. Any questions on that, you guys? Okay, give me a thermometer. Okay, I'm seeing this. Tell me about that. If you don't like the chart, then you can do it mathematically. So it's okay, but what the chart represents, so let me take a second and just slow down and like make sure you do understand the chart, because it is helpful when we get to combined events with dependent events. So this represents the first coin, right? So the first thing that I draw. So I can either have a nickel, dime, quarter, right? That represents the second coin that I draw, nickel, dime, quarter. All right. This square represents that I drew a nickel and a nickel. This square represents that I drew a dime and then a nickel. This square represents that I drew a quarter and then a nickel. Does it make sense now? And so what they've circled is each of the outcomes where the 2 coins are, the same coins are drawn one right after the other. Okay. All right, Emma randomly draws a card from a stack comprising 1 red card, 2 blue cards, and 2 green cards. She then returns the card to the stack and draws a second card. Find the probability that the 2 cards drawn are different colors. Okay, so you can see from the chart, again, up here, there's our first card. And so we've circled the draws where we've got 2 different cards, right? So we would circle this blue and then red and then blue and then red and then green and then red and so on. Any questions about how that chart is constructed? Does it make sense to everybody? All right, first of all, how many outcomes can I possibly have? 25, right? Which makes sense because I have 5 cards. Yeah, so 5 times 5 is 25. Good. How many possibilities do I have? Okay, 16. Good. So can you explain how you got there? Okay, that works. You can totally just count the circles. Good. So 16 possibilities. So what's my probability now? Easy answer, guys. What's my probability? Remember, it's favorable, it's possibilities out of outcomes. Elijah? It would be 16 out of 25. Great job. 64%. So if we were to go ahead and remember how we set that up, you guys, 16 out of 25 times 100. Oh, you know what I like better on this one? Times 4/4. And then we get 64 over 100. So copy that down, please, because I feel like we need a refresher on percentages here. Okay, moving right on. Do you have a question or a comment? Okay. Well, what we're looking at right here means 16 divided by 25. Read it from top to bottom. So if you want to find the percentage of something like a fraction, there are two ways. If it's a friendly denominator, like 25, you can multiply by a factor to make it 100, right? Because remember, percent is a special fraction out of 100. If it's not a friendly denominator, then you can multiply by 100 over 1, and whatever you get is your percentage. There's a third way, and that would be, like you said, to divide 16 by 25. That would be converting it to a decimal. Then you would again need to multiply by 100, because then you would need to move the decimal place. Okay, here we go again. Just Rose. Rose tosses a coin 2 times. What is the probability that she gets 1 head and 1 tail? All right, so we've got 2 methods. Number 1 is a possibility. That's what we've been doing, right? We've got first toss, head, tail, second toss, head, tail. What's the probability that she'll get 1 head and 1 tail, right? 1/2, good job. So there are 4 possible outcomes. This should be 2, not 1. 2 possibilities, and the probability is 1/2. Great job. Okay, here's another method for you guys. This is called a tree diagram. This is really helpful when we get some more complicated problems where we have, like, say, 3 events. So what we would do was so here's our first toss, heads or tails, right? I could do either one of those. On my second toss, I might either get a heads or a tails for each of those. My outcomes then, so we would read this from left to right, would be heads, that's this one, or heads, tails, that's this one. Does that make sense, you guys? Or tails, head, or tails, tails. And so it doesn't really change anything. Our probability is still 1/2 on that. So are we good? Anybody like, that tree diagram is scary. It's okay if it's, say it's scary. You sure? It's a cute diagram. This next one's not so cute. So here's the deal with the tree diagrams, you guys. They do look kind of overwhelming, but if you break it down, they do make sense. So yeah, Alex, go ahead. Yeah. Yep. Yeah. Exactly. That's exactly right. So you do have to take they're not as easy to read as the tables, I don't think, but yeah, they are intuitive. So good job figuring that out. Okay, so this time we've got a spinner board consisting of 3 equal parts colored red, green, and blue. Sam spins the spinner twice. Find the probability that the needle points to red both times. Okay, so here are all of our possibilities. On the first spin, we could get red, blue, or green. And then for each first spin possibility, we have 3 second spin possibilities, right, you guys? Okay, does that make sense to everybody? Okay, so if we're finding the probability that the needle points to red both times, and we're just looking at this, aren't we? Red, red. But we need to be able to diagram all of the outcomes, because we need to know how many outcomes there possibly are, don't we? Okay, so how many outcomes are there? How many? 9, okay. So our probability would be 1/9. Okay, so here's the other method, and this is the mathematical method. Since for every 3 outcomes of the first, what are these spins? We have 3 outcomes of the second spins. We could phrase it like this to help us remember how to do this. 1/3 of the time, we might spin red, right? 1/3 of the 1/3 times, we would spin red again. Does that make sense? What does of mean in math? Okay, so then I just verbally set that up for you. So what do I multiply to find the probability? What is it? 1/3 times 1/3. Does that make, yeah, right? 1/3 of the times I would spin red. 1/3 of those times, 1/3 of 1/3. So 1/3 times 1/3, 1/9. Okay. It totally makes sense. Probability is fun. It's simple. It kind of is. All right, Patty tosses a coin 3 times. Find the probability that she gets tails 3 times. Okay, find the probability from the tree diagram. What's the probability that she's going to get tails 3 times? Well, how many outcomes are there, you guys? Well, no, we're looking at the outcomes right here. How many are those? Okay, equals 8. Out of those outcomes, how many times does she get tails, Austin? Once, exactly. All right, so our probability is 1/8. We're looking at this. Gosh, now we have 3 events. That's kind of a lot, isn't it? All right, let's set this up mathematically. Who can help me out with that, do you think? Gabby?
1/2 times 1/2 times 1/2.
Yeah, 1/2 times 1/2 times 1/2. Great job. Okay, so the first toss is 1/2, right? Probability that she'll roll a tails, flip a tails or whatever. And then the second time is 1/2, and the third time is 1/2. So it's 1/2 times 1/2 times 1/2, which equals 1/8. Is our math right? How are we doing? Okay. All right. The probability that will rain on a given summer day in town. Hold on, first of all, did everybody get this and copy this down?
Yeah.
Are you sure? Because I don't think everybody did. You did, good job. Okay, Liam? That's a mistake. You can cross that off. Sometimes when we make the PowerPoints, we copy and paste and it just doesn't get copied and pasted correctly. Okay, so number 6, the probability that will rain on a given summer day in town is 0.2. First of all, let's break that down. What does that mean? Charlie, what does that mean? Okay, it's a 20% chance of rain, or 2 out of 10 days it might rain, or 1 out of 5. Find the probability that it will rain on, 2 consecutive summer days in town. Let's break this down. Does whether or not it's going to rain the second day depend on the first day? So are these independent events? Yes or no?
No.
Is there a magical switch where if it rains on a particular day, it's not going to rain on the second day? No, these are independent events. Will the probability be lower though? That's going to rain 2 days in a row? Yes, because it's already only like 20% chance that it's going to rain that first day. Okay, so here's our probability chart, right? So we've got day 1 up here, and this symbolizes rain, sun, 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 and then here's day 2. Okay, and so the X's just stand for all of the possible outcomes, and we're just going to circle the one that represents 2 days in a row of rain. And so there's only one of them. So what's the probability that you can deduce from the chart that it's going to rain 2 days in a row? Can you tell me, Tyler? Give me it as a fraction. How many outcomes do you see here? And to find the outcomes, you can just really quickly multiply, right? We've got five possibilities on one axis and 5 possibilities on the other axis. 1 out of what? 1 out of 25. Good job. Okay. There we go. There it is. Let's find this using method 2. How would we set this up with method 2? So just mathematically, I'm not going to use the chart this time. Anthony? 1/5 times 1/5. Good, because on the first day, there's a 1/5 chance, right? On the second day, there's a 1/5 chance. So it's 1/5 times 1/5. Does that equal the right thing? Yep, it sure does. Good. So 1 out of 25. All right, I'm gonna pause us for a second here. And then I have you guys fill out the last 3 here on your own. Okay, so I'm gonna give you about 2 minutes or so to do that. And we'll reconnoiter in a couple minutes. 3 different methods to solve the same problem. Did you come up with the same answer every time? No? What's that? Well, I wanted you to understand how to do it though, 3 different ways. Well, let's take a look here. All right, so the first method that we have is the possibility diagram. And so since we have 6 possibilities on the first row and 6 possibilities on the second row, we should have a chart that's 6 by 6. And how many outcomes should we have? How many possible outcomes, Elin? 36, good, 6 times 6, okay? Out of those 36, how many times could Deborah roll a 6 the first time and an odd number the second time? Ashley? Yep, so we've got those circled here. So 3 out of 36 times, okay? So we should have that copied into your notes, you guys. So our probability is 1/12. Everybody have that? Yeah, great. Next method, the possibility tree. Okay, here's our first roll. And then our second roll. Notice for every roll on that first time, we have 6 possibilities for the second roll. So how many outcomes do we have this time? Okay, guys, I should probably hear a lot more of that right now. Okay, good. 36. It's still 36, even though it's a different way of illustrating it. All right, so I still have 36 possibilities. Out of those 36 possibilities, now we're only going to look at the 6. How many times might she roll an odd number? Eyes up here, please. How many times, Annie? 3. 1, 2, 3. So what's my probability this time, guys? Yeah, it's still 1/12. Isn't that crazy? Okay. Mathematically, what do I multiply by? What's my setup here, you guys? Kinsey, I need your eyes up here. Thank you. Okay, third one. What do I multiply by? Make sure you guys are getting these notes each time through. Okay, Liam.
1, 6.
Okay, let's think about this again. My first roll, there's a possibility there in 1 out of 6 times she's going to roll 6, right? But the second roll, we want to know what's the possibility or the probability that she's going to roll an odd number the second time. Out of 6 possibilities, how many are odd? Gabby? 3. So on that second roll, it's 3 out of 6. So it's 1/6 times 1/2, you guys. Can we show star, please? Thank you. Yep. Thank you. Annie. Okay. Let's talk through it again. It's okay. Is anybody confused by that? Anybody else? It's okay if you are. I want to keep it on the chart so you guys can see. Okay. So we're multiplying the second roll times the first roll, right? What's my probability that she's going to roll a 6 on the first roll, class? 1/6, right? Okay, with that second die, what's my probability that she's gonna roll an odd number? 3/6. 3/6, which is 1/2. So it's 1/6 times 1/2. Yeah,
Could you just do 1/6 times 6?
you sure could. Yeah, you could totally do that. And if that's makes more sense to you, 100%. Because now we can go like that. And we can cross cancel, and then we get the same answer that we should have gotten. 112. Okay, so when you're doing this mathematically, friends, you're gonna multiply the probability of the first event times the probability of the second event, and they might be different. So you have to take that into account. All right, let's go ahead and start homework. Your homework is workbook exercise 4.